Okay, so far we saw shifts along for amplitude time periods, and then putting it all together, we can also have shifts along the x-axis, right? So for example here, you want to go from sine x to sine of x minus pi over 3. So this is what sine x looks like. Now x minus pi over 3 means you're moving this on one of them, left or right. So you go back to transformations here. Minus a means you're moving to the right. So how much are you moving this to the right? Is you're moving it to the right by pi over 3. Now it's important to keep the time period constant, right? The time period has to be 2 pi. So if you move this graph to the right by pi over 3, right? So it's going to be somewhere here. So it starts at pi over 3. To find this point, you just add pi over 3 to 2 pi, and that's 7 pi over 3. And this is pi over 3. However, remember the sine graph keeps on going like that. So this would be somewhere here. But we still want to plot this in the original time frame of 0 to 2 pi. So at 2 pi, it's somewhere here, and this height should match up. So now this graph is going to look somewhat like cosine, right? But not entirely, because this is pi over 3 and not pi over 2. So which means this is not exactly -1. Now here, a lot of things happening here. You have a 2 here, you have a 3 here, you have a subtraction here. Right, so one way to go about this is to go from sine x to 3 sine x to 3 sine 2x to 3 sine 2x minus pi over 2. Right, because if you distribute this 2, this is 2x minus pi over 2. Or you can also go sine x to sine x minus pi over 4 to sine 2 times x minus pi over 4 to 3 times sine 2 times x minus pi over 4. Now these transformations are independent of order, so you can go in any order as long as you're doing one transformation at a time and you're doing it correctly. I'm going to use this. So I start with sine 0, 2 pi, 1, -1. First is an amplitude change, so it just becomes bigger, doesn't mess with the time period. Then it messes with the time period, it gets squished. So this is now pi, this is 3 and -3, and then it moves to the right by pi over 2. So this right here is pi over 2. So it moves here. And this is going to be 3 pi over 2. But I want to cut it off at pi. So my actual graph is just going to be that. With this is -3 and this is +3. So in conclusion, when you take a graph like sine x to k times sine x, the time period remains 2 pi, but the amplitude becomes k. If you take a graph like sine x to sine of kx, the amplitude remains 1, but the time period becomes 2 pi divided by k. Yeah, so if it's 2x, the time period is now pi. If it's half x, the time period becomes 4 pi. Let's see. Okay, in the next video, I'm going to show you how to use this online tool called Desmos, with which you can play around and look at a bunch of graphs really fast. But at the same time, it's also essential to be able to do these by hand and really understand what these transformations are doing. Okay, so that's the end of this video.